So now three-dimensional part 10, distance of a point from a plane. This is a point whose distance from this plane we have to find out. The equation of this plane is r dot n is equal to d. Okay. P is a point whose coordinates, if we go for the Cartesian coordinate system, then we will define the coordinates. First, we will do the vector form. So OA, we can take this as A, P or A, no matter. So this is vector A, vector A. Position vector of point P is vector A, and this is the plane. You have to find the perpendicular distance of a point from the plane. Chalo, I'll write this one also. So this P, and let's take this point Q. PQ distance we have to find, that is D. So PQ distance, if you remember in 2D, when these are the extended form of 2D generally. When we were finding the perpendicular distance from a point, if you remember this is the point x1, y1, and from this we have to find the perpendicular distance of the point from the line, and line is having x1 ax plus b ax plus by plus is equal to c or plus c is equal to 0 in 2D. So then we are putting the values of x1, y1 and under root a square plus b square. Similarly, here also same thing, but in 3D manner. So you have to see how to do in 3D. In 3D, this r is replaced by vector a, because we are putting the values of a. Okay, so therefore if you replace and bring on the left side, so that is distance PQ that can be denoted by D will be equal to a vector a. R is replaced by vector a dot n minus t divided by vector n divided by magnitude of vector n, or divided by magnitude of vector n, correct. So this is the perpendicular distance formula. In where a is the vector, if we write in the Cartesian coordinate system, is the vector whose coordinates are point P, the coordinates of point P x1, y1, z1. Therefore, the position vector of P is A, that is equal to x1 I, y1 j cap plus z1 k cap. And normal vector n, this is vector n, normal vector n. So if we go for Cartesian coordinate system, we can use capital N, also we can use, or a small n, doesn't matter. So here n vector is equal to a I plus b j plus c k. Okay, so if it is given in the Cartesian form, that means the equation of the plane, if the equation of plane will be given as ax plus by plus cz is equal to d in the Cartesian form. This is the equation of a plane in the Cartesian form. Then drs of the normal will be, I told you this is the drs of the normal, and drs of the plane are same ABC. That's why n can be written as like this. Okay. So then when you will put these values in this equation, so you will get the result a dot n. A dot n means ax1 plus by1 plus by1 plus cz1 minus d. If this d is considered, because here capital D we are taking, so this will be d under the root a square plus b square plus c square, a square plus b square plus c square, and absolute value of this one. Got it? We can write properly here minus d. One more thing, if you can see that this point, if this point P will become origin, means if we have to find the distance from the origin, okay, so this A vector will become 0. So perpendicular distance, if we want to find the perpendicular distance from this formula, perpendicular distance of plane from origin. From origin means that is A will become, here in vector form, vector A will become 0. So if you put 0 here in this equation, so in the vector form you will get just d, not sorry, not vector, d minus t upon n vector. This is the perpendicular distance, and that also comes when, suppose this is the equation of a plane. If you want to find this is the d distance from anywhere, but if you want to find the distance from the origin to this plane, so make it a unit vector. So divide both the sides. I think I told you, when you divide both the sides by magnitude of n, d is also divided by the magnitude of n, then this will become r dot unit vector, and this distance will become the distance from the origin, d upon n. So this will convert into the normal form, and this distance will be the distance from the origin, which you can see this is the same as this one. So I think you understood that when P will be taken at O, okay, so then that will become, this distance PQ will become the distance from the origin. And when P will come at O, this A vector will become 0. So that's why I have taken A vector 0. And this value A vector you have to put here. When you will put 0 here, 0 into n, 0 minus t. So that's absolute value of minus d upon n vector. This is the distance of the plane from the origin. Okay. Another thing that in the starting I told you, there are two types of equations. One where the n vector is given, here n vector is given, and one is there where n cap is given. So if n vector is given, n vector is any normal vector to the plane, but n cap is the perpendicular from the, means perpendicular normal from O to, from origin to the plane. N cap is the normal from the origin to the plane. So that's why it is called n cap unit vector. So in order to make it unit vector, we have done in vectors also. Vector divided by its magnitude will become a unit vector. So in order to make it a unit vector, we have to divide both the sides by the magnitude of n. So right hand side, you will get the distance from the origin to the vector, because it is a normal form. This has become a normal form. In the normal form, n is the unit vector which is joining from center to the perpendicular from origin to the plane, and this right side is the distance OQ. That will become OQ here. In this case, OQ is the d upon n cap. Okay, got it? This is a given plane, and this is the line whose vector is vector b. This is a line, vector b. And we have to find the angle between the plane and the line. So that will be actually this one. If you draw a line on the plane, then this angle we have to find out. We will take it as phi. But it's difficult to find out this angle. So what we will do, we will draw a normal to the plane at this point. Normal to the plane at this point. Draw a normal to the plane. Okay. This is the normal to the plane n. N. As I told you, normal. What is normal? Before I told. Now we have this line. What is the equation of the line? This line has the equation r a plus lambda b. Is the equation of a line passing through point A and parallel to vector b. And plane, the equation of a plane is r dot n is equal to d. Okay. Then now we have to find the angle between the line and the plane. So what we will do, this is 90 degree. This normal is always perpendicular to the line which is lying on the plane, any line. So that means what we will do, we will find the angle between these two vectors, because we know this vector b is given, this vector n is given. So from these two vectors, we can find the value of angle cos theta. So we can write the formula of cos theta. Therefore, cos theta is the angle between the normal and this line. So cos theta will be equal to n dot b divided by magnitude of n into magnitude of p. Okay, got it? But we need to find phi. What is the value of phi? Phi is equal to, you can write 90 degree minus theta. 90 degree minus theta is what? Phi. Okay. So if you will take sine phi here, so sine phi will be equal to sine 90 minus theta. And sine 90 minus theta is equal to cos theta. So therefore cos theta is equal to, so therefore sine phi also equal to n dot b upon magnitude of n into magnitude of b. Okay.